So, we have a lot to cover, so excuse me if I'm rushing into things. I'm trying not to, but it's a habit. We are going to talk about fun and profit on MQTT. MQTT as a protocol is, we're going to talk about the protocol itself, some from the basics up to the novice, and maybe if you want to exploit it and maybe you want to explore it. Whatever your task is or whatever your agenda is, I think you'll find something interesting within those slides. Okay, so fun and profit in MQTT. First of all, the mandatory, I work at a firm. That doesn't work. It did work, so just a second. Never mind. I work at a firm named Variant, and they are generous enough to send me here instead of walking. I'm a security research manager there. I'm having like around 20 years in security, depends how you count it. Cyber wasn't existed, so I can't count cyber in 20 years. I'm pretty active in the community in Israel, and I'm leading several groups in Variant. Brilliant people that are doing amazing job, and I have to give it to them. They're truly amazing, and we are looking, of course. That's it. You will never hear about Variant again. I'm sorry. Okay. So MQTT, we're going to cover the basics. We're going to talk about the protocol itself, what is secure about the protocol, and what is insecure about the protocol. Of course, we are interested in insecurity of something, but it is important in order to complete the complete image in your head, you have to understand the security of it. So we talk about the broken stuff and the fixed stuff. And then for the fun part and for the profit part, reconnaissance, how do we discover those machines on the internet or maybe on corporate networks or home networks, how to abuse those machines. So I have several examples. And at the end, a live demo, you can, maybe some of you can see the blinking light there. There is a green LED on the table. I'll try maybe to raise it up more when the demo is live. I'm going to show a live demo on exploitation of those networks and a specific device that we're going to talk elaborately about. Okay, and of course there will be some time for Q&A, and if not, I'm here. You can ask me in the corridor. I'm very happy to answer any question. Okay, I'm keeping forgetting that it doesn't work. MQTT stands for Message Queue Telemetry Transport. If you are familiar with any kind of messaging queue protocols, you'll be straight at home. No? No. You'll be at home and feeling comfortable at MQTT. It's a dumbed down version just for very basic sensors and machines. And when we are talking IoT's, embedded systems are pretty basic when we cover CPU, RAM, and maybe even storage capacity, which is not comparable to any kind of modern CPU. Even the most expensive and robust embedded systems are not comparable to any modern CPU, RAM, or whatever PC you are having on your desktop. So the thing with MQTT is we want to connect devices to one single point of, or like a hub or something. If we have a hub and we want to connect all those things together, or we want to connect all the things, that's a good idea. We have an IoT's around, and we want them to talk in a specific protocol and be acknowledging one another, and maybe some central point of aggregation of this info. At the end, when we are talking about MQTT, we are constantly talking about IoT's, but it doesn't have to be IoT's. You can use your mobile phone, and we have an example for that, to talk in MQTT or specifically any kind of application that you have, a desktop or maybe a mobile application, and of course the native way of looking at it, it's embedded systems because of its very dumbed down version of MQ. What it means is, for example, it's a publish-subscribe protocol. Pretty easy. We have here a sensor and we have a mobile device. The mobile device can be anything. But we have a sensor, a very dumbed-down sensor. The sensor itself For this example, it's a temperature sensor, and it has something that is called, we have 4 terminologies that you have to remember. One is the sensor, which is called a client or a sensor. It's synonymous in the protocols. The other one is the subscriber. So you have a subscriber, you have a publisher, you have a broker, and you have a sensor. Those are the 4 terminology that you have to cover. The first one that we said, sensor, is the one that is representing something that want to publish some kind of information, and maybe to resolve some kind of information for someone else. We have the broker, which is a centralized computer. In my demo, I'm using a Raspberry Pi for that, but you can use any kind of machine or server that you have to use as a broker for all the message queue to be arranged in some sense. The other one that you have is a topic. Topic, like you say, is some kind of a channel for that. Every topic have a hierarchy. We'll get to it later. We have the weather /TLV. TLV is Tel Aviv, stands for Tel Aviv. And when we are approaching this subscription, it is subscribed to weather /TLV, meaning that he wants to get updates on the channel named weather /TLV. Now the sensor is subscribed to it, and then another mobile device is subscribed to weather TLV as well, up there, and then it publishes pub to topic weather TLV value 29C, 29 Celsius. It's pretty okay for Tel Aviv summer. And when we have 29C, it just publishes to the broker receives it, thinks about it for a second, and resolves whoever needs to get this information, who is subscribed to this topic. It resolves that the mobile device that we're using is subscribed to it, so the broker publishes the information on to the mobile device, and then we know what is the weather according to our sensor. That's it. Of course, it's a simplification of the stuff, but not very far from the truth, for the complete truth. What we are missing here is essentially disconnect requests, which are important but are not covered in this simple diagram. Appropriate acknowledges of those requests. QoS, which is a very major thing in MQTT protocol if you are using it, but for us as hackers, less interesting for this talk. We have 3 levels of QoS. It means some kind of how many times or how persistent the message is. And we have a keep alive, which is, of course, in any kind of protocol you will achieve a keep alive just for the system to have a go and nothing will break in the middle. Can I have the clicker? Thanks. So, thank you. Oh, now it's working? Oh, no. No, that doesn't matter. I just need that. That is working. Thank you. For a broader example, we have the weather topic. Under the weather topic, we have 3 other topics. It's in hierarchy, as we said. So we have weather /TLV /humidity, and maybe we have weather /TLV /temp. Maybe we have weather ger, like Jerusalem, weather ger and temp. In those examples, we only see the 3 topics. The final topic in that equation will be weather TLV humidity, and according to that logic, you will have 3 topics in general. When we want to subscribe to something specific, we have to specify whatever the name of the topic is. The full hierarchy is required. If we don't know, or if we don't want to know the exact subscription path, we just want to be subscribed to any kind of TLV topic, we are subscribing to weather /TLV /pound or hash. Now, when we are subscribing to hashes, we will have it's like a wildcard. You will have anything under TLV. So when you are subscribed with one subscription, you are subscribed both to humidity and both to temp. The other one is the weather plus. Plus is saying that complete the missing topic in between. If we are using plus here, we are having weather plus temp. It means weather /plus/temp. It means that either weather TLV temp and weather Jerusalem temp will be applicable and will be subscribed by a single subscription. It's pretty useful for any kind of, like, if you have like a screen that you want to monitor all those sensors, and maybe you want to simplify your work, you are using those nice wildcards. Of course, I'm not just mentioning it, it will be applicable to our work as well as penetration testers or ethical hackers. Okay. Real-world usage for MQTT nowadays is mainly considered home automation devices that are using MQTT. It's pretty common. The trend in the corporations are towards home automation. We have practically every major manufacturer is working towards implementing MQTT in these devices. It can be your lamps, it can be your cat feeder, it can be anything like that. And another, I'll say minor, but because of the usage in Facebook, it becomes much more bigger implementation, but the minor thing is for a simplified messaging protocol. Facebook Messenger is based in its infrastructure on MQTT. They delivered this information quite a while back, and it's pretty fascinating. It's the only example that I have of a true-to-life, very big infrastructure that is using MQTT as a protocol for messaging. So that's interesting, but when we are looking at it, we are usually looking at smart home automation. Now, the biggest competitors in the market, which are cloud-based, which everyone are talking with the cloud today. So we have AWS IoT, and we have the Microsoft IoT Hub, which is a broker from Microsoft Cloud, which you can lease and then use it for your specific domain. Now, when people are hearing about home automation, they are using home automation in many specific ways. Everyone can look at it in a different angle. And when I'm talking to people about MQTT and trying to explain what it is and trying to have multiple examples of how to use it, there are two kind of reactions for people. The first reaction is, okay, I get it, that's cool, and specifically, wow, that's awesome, I can use it with my, okay, when it's weather outside, I can sense the weather outside and then shut up the shades, and then the cat needs to eat more and maybe have my bathtub filled for some reason in time when I get from work, and it will be completely amazing. I'm amazed by this computer technology. This computer stuff works, and it's awesome. The other reaction is basically that. I'll read it out without the profanities. When the F did we all become so effing lazy? What is the actual F is this crap? And this was according to Phillips, showing a very complete, very complex diagram in the AWS summit about how to, this diagram is basically how to turn on and off the light at your home. And if you can see the diagram, it's mainly comprised by, I don't know, like 20 components instead of one switch that you need to bring on and off. But of course, it's the whole infrastructure, and Philips were very proud of it. But this reaction it's so common that I have to bring it on to this screen. Whatever you're feeling toward MQTT, it doesn't matter for this talk, because whatever you think it's worth it or not, it will be worth it for us as security professionals. And that's why. But before the broken stuff, we'll talk about the fixed or well-designed stuff. First of all, MQTT looks and feels like a modern protocol, something that is very aware for security considerations, theoretical, I should say, security considerations. It has multiple ways to authenticate. You have a user password, you have a TLS, you have even a client certificate implemented within the protocol itself, and of course recommended by the protocol to use. So that's great. We all love client certificates and TLS. User password is okay as well, and you can talk by plain TCP, some specific serialization, and you can talk by WebSockets, which generalize the idea for HTTP, etc., etc. Even permissions have specific chapters, and those are, you can set permissions per topic, you can set permissions per method, either publish or subscription. And per QoS, as I mentioned, I'm digressing because that QoS is not part of the talk, but it is important to say that there is an option for that as well, which is pretty good in my opinion. The permission model is pretty robust, and you can do a lot with this kind of lightweight approach. Okay, but of course we wouldn't be here without the insecurities of things. Many of the devices, and the one that I'm showing here is a good example for that, are pretty small in size, both in size and both in computer power. If you are trying to do TLS, you will have to use something more robust than my small 24 or 52 megahertz machine. Even in the code for this device that I'm using here, there is a comment that I will show later about not to use TLS because it's really, really the memory consumption is too big for this. It's just recommended not to use it. So that's why I said theoretical requirements for the protocol are great, but in practice it will be very hard for many of those to be successfully implemented and securely implemented. And currently, when you are approaching MQTT, you have to be some kind of a technology, tech savvy in order to actually protect it. Everyone can bring up an MQTT server. Everyone can set up her or his home automation systems. But of course, to really know what you're doing without confusing security with something else, you have to know what you're doing, and you have to work with Vim, Emacs, or whatever to actually work with the config file. But to be fair, the second thing is something that is evolving. I guess in a few years we will see more and more robust systems and more automatic systems to do this kind of work. So I guess the second thing is mainly temporary. What else we have? Actually, the biggest problem I have with MQTT, and I'm seeing it all over the internet, is the thing that permissions for the topics are set on the broker. You have to be on the broker, let's say on my Raspberry Pi, and configure what kind of permission that I want to each and every topic that I would like. That's a problem, and why it's a problem. It requires me, as someone that is setting up the sensor, to really know what I'm doing. It's not so easy sometimes. It requires me to know every kind of topic that I want and what kind of permission model I want to implement under it, and I have to really know what it's doing, not just what the documentation says. In this example, I actually read through the code and found a topic that it wasn't documented anywhere, and without this knowledge, I would not able to pin down this topic and set a wise permission on it. So that's a big problem, and of course I have to really understand what each and every topic can do to our systems when it is implemented. By default, we have, I didn't mention it, but the brokers over the internet are partly fragmentized, and mainly like 80% or 79% of the total around 2,000 brokers that I scanned on the internet and excavated some information about them, presented it with a server called Mosquito. Mosquito is the open source alternative for other things, and it shouldn't be a surprise for you. Everyone that wants to have a home automation will not buy the complete IBM package for MQ. He will use the convenient way of open sourcing and buy a cloud server and then put at a server his broker there. So by default, when it's out of the box, you just install it. You have authorization by default, so it means so no one needs to be authenticated to the system. Everyone are authorized. In other words, you have an anonymous access to your topics unless you set it otherwise. You can set it otherwise, but generally speaking, as I said, 79% of the machines that I've scanned from 2,000 machines overall used Mosquito, and around 80 to 75% of them were not permission-based at all. You can search and traverse any kind of topic that you wanted. When you have a super protected channel, when you have, let's say, SSL and TLS, it doesn't mean that the broker is safe and no one can access it. That leads me to another CVE that I brought up on the Mosquito, but again, it's nothing that important for this talk. Okay, I've mentioned that embedded systems are not strong enough to hold this kind of connection, and in Arduino it's pretty very limited, because it says on the documentation for Arduino client for MQTT that TLS SSL is not supported at all. You don't have the option to have it on, even if you like to, but you won't be able to do it with an Arduino. But let's say you don't have an Arduino and you have this kind of son-off. Son-off is the device that is mentioning time and again in this presentation and demo. Son-off is a switch, a very small device that only switch on and off wherever you like. It's just you need to connect it to some kind of electricity circuit and then to switch it on and off. It's pretty practical because you can turn any kind of home machine into automatic system and into something that you can control by on and off the machine itself. But in its documentation, I already mentioned it, it's written pretty strongly. TLS uses a lot of memory, 20K, that's a lot of memory for that. So be careful to enable other options at a time. It means not to disable, but to enable. Be careful about what you enable, I guess. So that's massive, and of course, by default, it is not part of the not part of the firmware. You have to compile the firmware yourself and to enable the SSL. Without it, it won't be compliant to SSL, whatever you, even if you want to. You won't be able to turn it on. So that's just making the point about IoT devices have limited memory, and you can't just think because of the protocol says it has SSL TLS. Practically, it isn't the case. Okay. IoT devices have, I haven't mentioned one specific vulnerability that is very common in IoT, which I personally like. Someone can guess what is the vulnerability in IoT in general? Only one. No? Okay, I guess that you are shy. It's features. That's the biggest vulnerability for IoT. Features are there to stay. Features are there for reasons, for any kind of reason that someone thought of, and those reasons are very exhausting for security guys like us, because we want to disable it, but many times we won't have the option to disable it, even if we want to. Okay, let's get to part of funnel profit. When we're talking funnel profit, that's how you discover those machines on the internet. If you scan, if you use Shodanit, if you just mass scan the internet, you'll get those default ports. That's the straightforward way to do it. That's the different default ports on the internet. Other than that, you can show them for MQTT and specific ports, as we said, and even Mosquito itself will show up time and again. According to topics on Mosquito, if you are using, if you are approaching a Mosquito, and that's a common standard. So even if it's not a Mosquito, most of those topics will be relevant. You can use any kind of topic. Pay attention to the $sign. $sign says that you can't use wildcards within it. So that's why I have to list all the topics that you have to subscribe to in order to get information from the system. And some of them are pretty interesting and worth your while if you are into MQTT. So it's just there, anyone can use it and try to figure out what kind of information you can get from the MQTT broker. Okay. Some common examples for topics that I saw are mentioned here. There are much more, but these are prominent and we see it all the time. And we'll focus on two of them. One is the own tracks. We'll use it in a second. It's a mobile GPS tracking. It actually, you turn your mobile device into an MQTT client, and then you can track your kids, maybe your spouse or whatever you need. That's a very common example of people that using MQTT. And the other one, of course, that we already mentioned is the son-off, sometimes named IoT's, sometimes named DVS, for multiple examples. If you want to hack into saunas in Sweden, you can use Z-Wave, but whatever you find fancy. Okay. So those are common topics that you can look at and understand what is behind the broker. Now, topics that are less common but that are still gems that you can find, those are all topics, not information from the topic, that's the topic name. In this example, I don't think you can see it because of the lights. Maybe someone dim out the lights to be better, but I can read it out. It says something, info -f robert.json -r -u, some kind of a username, -p, some kind of a password, and then it all over again, the port that is using, the CA file that is using, etc. the person that brought out the Mosquito server there apparently used some kind of a bash file to install the topics that he wanted, but it entered as topics, but not as the actual data into the bash file, into the bash prompt for some reason. And of course, I won't recommend any of you to use those credentials against its SSH port, which is happened to be open to the world. I won't recommend it. Another example is that I found this one, which is unreadable at all. It's pretty small. I'm sorry, but actually, what it says is we have a lot of tryout of SQL injections. Now, SQL injections shouldn't be here, right? It's not an SQL server. No one's supposed to ask it SQL. So I converge into two analyses. One is that someone tried to home down, like he's pointed his laser of a SQL map or something into this port and try whatever topics. It's less probable. But what is more probable, that is before the MQTT broker, there is a web interface. If someone wanted to fuzz out and try to fuzz it with SQL map or whatever tool he used, and those are entered as topics. That's important to say. A broker will accept any topic of a publishing topic if you have anything in mind. You can call a topic whatever you want. The broker will accept it unless it's not default configuration of the broker. So keep that in mind, and that's why this is a good example of topic misdirection. And what I don't show here is that it contains more than 50,000 lines of topics before I just ended the session because it wasn't important for me. So okay, SQL injection is again something weird. Two examples. One is the on-tracks. On-tracks is you can do Sterling Archer type of global spying. You can subscribe to a broker with an on-track topic and just listen to whoever walks on the street. The one that I presenting here is a real-world example of Paul. I don't know Paul, so excuse me. He has apparently an iPhone 6. I wasn't sure he's alive. I wasn't sure it's something that maybe it's a honeypot, maybe it's something else. I can't be sure anywhere, but I tried my luck and took those longitude and latitude coordinations and built up a script that just tried to plot his way along the 24 hours or 26 hours along the day to see if it's a real person. So first I just put it into Google Maps and tried to do my best in assessing where is it. So it's in Texas. That's, I guess, cool for someone. And in Texas I looked at the street that the latitude and longitude showed me. It showed this kind of building, a pretty, I don't know, pretty straightforward building, nothing special about that. But when I do a close-up on the title of the building, I read criminal court, which I assume it's, at this point, maybe it's a troll, and maybe someone tries to see if someone is listening to MQTT. But eventually, he did move this pole and walked around. I guess you can see it here, congestion on traffic, and maybe he walks home, maybe that's walk, I don't know, but anyway, it's pretty childish, I know, but I'm a child. The more practical way of looking at MQTT, if you are looking to exploit it, that's only leakage. That's something that you can benefit if you are looking into someone in specific, and maybe you will do some, I don't know, covert work. But more important for us is how we can use those for maybe converging on a botnet of our own, of IoT botnet. There is, I think it's on the other session, the Mirai botnet examples. But in this example, you want to do remote code execution on those devices. And there is a big problem about that, because you don't have a full-blown machine of a Linux or something. You have to be you have to be more knowledgeable about what you are running and how to run code on that. So in this example, and what we have here in the desktop is this kind of a small machine. You can see it has the blinking light here. It has a mains. You can just connect it to any kind of traffic. You have a big relay, which is great. It says on the box that is up to 10 amp but it isn't. I tried it. My kids got flashes in the house and thought it's fireworks. But don't try it. Don't try to amp up the amps. The other thing is that on the other side you have much more interesting stuff. You have the ESP8266. If any of you are familiar with embedded systems, that's a pretty trendy chip, which is an embedded system which supports onboard Wi-Fi. And this Wi-Fi is, of course, very important for us because we want it to connect to our network and then to the internet and then to have Internet of Things. So that's pretty nifty. You have here the serial connection that you can connect to. You can see it on the other end as well. But of course, it's all protected with this kind of plastic that we won't be able to access if we think of any kind of practical attacks over the internet. The plastic won't hold you back, of course, because we are looking at remote code execution. Okay, so what we are planning to show is that when researching this device, I figured that there are several topics of interest. And those topics were pretty decently documented, and I used this documentation in order to see what else can I get from it. Now, the most confusing part about it is that all the documentation said is that you can subscribe to those topics if you want, but what happens if you publish to it? We said that without permission-based, permission set on the broker, we won't be able to know who is sending what, and everyone can send publishing and maybe subscribing to the channels. So subscribing generally is not a bad thing unless subscription leads to leakage. But publishing is much more interesting, and we have to be much more knowledgeable about what we can publish and how it affects the system. So in this example, I'm just moving on to the actual example. We have several topics that those are part of the topics that were of interest to me. The first one is we can ask out what is the SSID. Before that, of course, I'm generally subscribing to hash, just all the topics that we can figure out what kind of topics are on the machine. I can't know it for sure, and maybe someone changed the names, so I want to be subscribing to anything I can for gathering those information. But the important stuff is the default CMND son of SSID, SSID2, password, password2. Why it's important? Because as you can guess, it reveals the SSID of the Wi-Fi and another backup SSID of the second Wi-Fi if someone set it up. And then you can actually use the the publish for the password if you want to set up the password. Now, that's not so bad, right? If you want to set up the password, you go ahead. It's, of course, something that you don't want because it will break your machine. But something else, if you send just the if you publish just the topic without any data, without payload, you will get back as a response the actual password which is on the machine. And now that's exactly the case with SSID, SSID2, password, password2, MQTT user, MQTT password. OTA URL is a very special topic. Why? OTA is over the air, of course. Over the air means it's a link to some kind of a firmware dump space, which you, or maybe in this case me, can see where to direct the device in order to download the new firmware. Now, it's supposed to be something that is within your domain, nothing in the internet, but you can select an internet device. In this case, that's exactly what I'm doing. And if I'm publishing to the OTA URL, I can update this field by myself. And then if I follow those steps and get the SSID, SSID2, password, password2, maybe the user also, but I don't have to, updating to the OTA URL to my URL with my evil firmware, and then I request an upgrade. I can push on the device to do an upgrade right now, not to wait for its sync, I don't know, let's say every midnight. I can push on an upgrade, and then it goes on to the OTA URL, downloads the new firmware that I planted it there, and then it's resolved with a remote code execution by firmware upload. It's pretty, and of course what I did, and I show it in the demo, if my prayers to the demo guides succeeded, will see a remote connection, a reverse remote connection by this, and you won't lose anything of the functionality because I'm based on the original firmware, just a modification to connect back to my machine. Through that process, I actually ran it on the internet a bit, and what I saw, I completed a list of around 1,000 IoT devices which responded to me with the Wi-Fi and password which I collected and generally showed, but of course without the details. I don't want anyone to harm directly from me, but of course you can do it by yourself right now. If you figure out the slides which are not complicated, of course, you can do the same and get the same results with 80% of the internet. Let's say 80 of 80%, because we said that 80% are MQTT, and then every son-off of them, let's say 80% of them are not authenticated, so you'll result with an 80% of 80%, which are 64%, I think. Okay, so this is the list. It goes on, and 1,000 devices leaked the password to me. This operation resulted with two firmwares that I've accomplished. One is the Son of Evil, which I'll show in a second, is the evil precedence of the actual firmware of Sonoff, just with a remote connection. Nothing, just a POC. It really, you can complete the details there and have another detail in it, but of course you have the Son of Evil right now, and you can do a POC by yourself, and maybe more than a POC. And more importantly for me is the Son of Angel. The Son of Angel is, again, a modification of the original firmware, which I went on and read all of it, of course, and complete the details on the documentation. And most importantly, I disabled by default the MQTT topics which are harmful for the Sonoff. I've listed all of them. I think it was like 12 or 14 topics, listed all of them, and the new firmware displays just the same functionality without the MQTT topics, that you can't publish it over the air. You have to have some other web interface, maybe some local interface, if you would like it to be that way. Okay, now it's the demo time. As I said, we should have a little prayer. If you, this kind of person, I'll explain a bit about the demo. We have the, oh, it's white on white, excuse me. We have the Raspberry Pi, which is a broker. We have the Sonoff, which is the device we're hacking. Here, the Arduino is only for power source. It regulates the power for 5 volt. Now I'm using something else of the Arduino. It's pretty bulky, but now I'm using something without the Arduino itself, just something that regulates here and just brings 5 volt into the Sonoff just for it to work. It's all connected to my Wi-Fi, and it's connected to the internet. And a thing that you can see here on the picture is my cloud server, which is sitting somewhere around the world, named I am Dalmos, and just waiting for the connection in a second. I'm reiterating one last time my process. I'm asking for SSID and password just to implement it within the firmware. So when it reboots, I will have the same Wi-Fi and passwords for the local Wi-Fi, so the user won't be able to notice anything changed. I'm compiling the Evil firmware with this data inside, hard-coded, and publishing the LTI URL with this compiled Evil firmware. And then I forcefully do an upgrade. Eventually, I will get a callback to my attacking machine. Thank you. Okay. Okay, I don't know what's going to happen. So, okay, I'll just extend the machine. Great, we have a connection to my, I'll let you see. Okay, I think that's enough. Someone can dim out the lights if it's possible. Not really? Okay. That's my machine. I'm just listening on my lead port. and I'm waiting for the connection. Of course, I'm just, I need to do the steps now. This is a very common MQTT. Oh, I see some connection problem. I will handle it in a second. That's an MQTT client which I can use in order to debug my machines or develop my MQTTs. I will just try to fix the connection. Okay, hopefully it will be the last time. Okay, and now I'm using this client just to publish all the steps that I said. Of course, we will start with the Wi-Fi, and we want to subscribe to all the topics. So I'm subscribing to all the topics, and we can see the topics are pushing into my screen. I can see, maybe you can see here it's an online. It says that the SON-off is online. That's good. And we want to, as we said, set off a topic publishing for command SON-off. We'll start with the SSID 2. Okay, and we get a result of MQTT demo, which is the same Wi-Fi which it's supposed to be. It has another one just for sake of proving my point. The other one is not a honeypot. It is. Don't use it. And if I have, if I'm pressing OK now, I would see the password for the Wi-Fi. I won't do it now. I'll do it at the end of the talk, so no one can mess with my presentation. Okay, another step is to use the OTI URL. I just want to see what OTI URL is presented right now, which is the, great, is the iamdalmos.com POC-good.bin. I guess you can't see that, I'm sorry. And now I want to publish my own iamdalmos POC evil.bin, and I'm publishing it. Hopefully it will suffice. Yes, now I can see even the result. The result is that OTI URL is now set on my POC evil firmware. Okay, now I need to push an upgrade. For pushing an upgrade, I just need a topic upgrade, and the payload should be 1. That's exactly what I'm doing. And I should see here that it should go offline. Yeah, it's offline. Now it will take about a minute. I didn't say that I already compiled. I'm not doing it live. The compilation is just taking time, that's all, for the sake of the demo. So it's offline. We can't see anything right now because it's still, the device itself is now downloading my firmware. It's not so big, but it's a small embedded system, so it will take like another 10 seconds maybe. Yeah, it's online. Successful restarting, that's great for me. And now we'll just try and wait for the reverse connection. It will take about 20 seconds, hopefully. Okay. Yeah, some problems with the connection, but it should be hacked. Thank you.